Good day, students. Welcome to our lesson this week in General Mathematics. In this session, we're going to discuss solving logarithmic equations and properties of logarithms. So remember, in our previous lesson, we can make use of logarithms to solve for exponential equations. For example, if the given equation is b raised to x equals a, we can express it as log or x equals log a over log b. Now, we can also expand logarithms. For example, we have log AB. So we can express this as log A plus log B. So again, log AB or log A times B, we can express it at log A plus log B. But if it is log A divided by B or log A over B, it will be expanded as log A minus log B. Okay? So log times AB, multiplication, log A plus log B, addition. Log A divided by B, division, it will be expressed as log A minus log B, subtraction. Then log A to the n, it can be expressed as n log A. For example, let us expand each logarithm. For number 1, log 4 times 9. So it can be expressed as log 4 plus log 9. So if you're going to check to your calculator, the answer for log 36 is the same as the answer for log 4 plus log 9. Then number 2, log x over 3. So that's log x minus log 3. And then log y squared. So this can be expressed as 2 log y. Then number 4, log 2x cubed or log the cube of 2x. So this can be expressed as 3 log 2x. So since we have 2 times x here, it can still be expanded. So this will be equal to 3 log 2 plus log x. Or we can distribute 3. So it will become 3 log 2 plus 3 log x. We can also condense an expression to a single logarithm. For example, we have 4 log 3 minus 4 log m. So observe the expression. So there's subtraction there. So since it has numerical coefficient before logarithm, so it can be exponent of the expression. So this can be expressed as log 3 to the 4 minus log m to the 4. Then, since there's subtraction, so we can express it as division. So log 3 to the 4 over log m raised to 4. Then we can express it also as log 3 to the m raised, or log 3 over m raised to 4. For number 6, 3 log x base 2 plus 3 log y base 2. So they have the same base, so there will be no problem. So you cannot combine two logarithms with different base. So if they have the same base, there's no problem. So this can be expressed as addition. So 3 log xy base 2. So multiply x and y. And then since we have 3 here, make it an exponent. So log xy cube base 2. Or we can also express it as log x cube y cube base 2. So here are some items that you can practice. So expand the following logarithms. And then the following items, condense each expression to a single logarithm. Now let's proceed to solving logarithmic equations. So remember, if log x base b is equal to log y base b, then x is equal to y. So they have the same base, okay? So for example, log 4p minus 2 base 3 equals log negative 5p plus 5 base 3. So they have the same base, therefore we can equate 4p minus 2 and negative 5p plus 5. Then just solve for p. So this will be 4p plus 5p equals 5 plus 2. 9p equals 7. So divide both sides by 9. You're going to have p equals 7 over 9. And that's the solution of this logarithmic equation. Example number 2, log 4k minus 5 equals log 2k minus 1. So if there's no base indicated, it means that the base is 10. Okay? So for base 10, they are not writing the base 10. So if you encounter given with this case, so it means that the base is 10. Okay? So log 4k minus 5 equals log 2k minus 1. So they have the same base, which is 10. So we can equate 4k minus 5 and 2k minus 1. Then just solve for k. This will be 4k minus 2k equals negative 1 plus 5. 2k equals 4. Divide both sides by 2. So k is equal to 2. So another example. Negative 10 plus log n plus 3 base 3 equals negative 10. So there's only one term here with the logarithm. So since there are terms which are constant, so you can combine it. So this will be log n plus 3 base 3 equals negative 10 plus 10. So negative 10 plus 10 is 0. So this will become log n plus 3 base 3 equals 0. So remember, we can express this. We can solve for n plus 3 here. We can express this as, remember, if log a base b is equal to x, then log a is equal to b raised to x. So we can express this now as n plus 3 equals 3 raised to 0. So 3 is the base, 0 is the exponent, then we have here n plus 3. And then 3 to the 0 is 1. Because any base, when it's raised to 0, the answer is 1. So we're going to have n plus 3 equals 1. So just continue your solution. N equals 1 minus 3. So n is equal to negative 2. And that's the solution of this logarithmic equation. Example 4, 2 log negative 2r base 7 equals 0. So recall, n log a base b is equal to log a base b raised, or log a to the n base b. So we can express this as log negative 2r raised to 2 base 7 equals 0. Then remember from our previous example, we can express this as negative 2r squared equals 7 to the 0. And 7 to the 0 is 1. When we square negative 2r, the result is 4r squared. So now we have 4r squared equals 1. Divide both sides by 4. So this will be r squared equals 1/4. Get the root of both sides of the equation. So now we have r equals square root of 1/4. So r equals positive or negative 1/2. So it means that the value of r is 1/2 and negative 1/2, or 1/2 or negative 1/2. Okay, so if we have two or more solutions for an equation, so use bracket, not parentheses, because if you use parentheses, it can be confused as interval or ordered pair. If you're going to use bracket, so it means that the solution is 1/2 and or negative 1/2. Okay, so more examples. Example 5, log 2 plus log x equals 1. So we can combine it. Log 2x equals 1. So remember, the base is 10. So express it in exponential form. So this will be 2x equals 10 raised to 1. Then 2x equals 10. Divide both sides by 2. X equals 5. Then example 6, log x minus log 2 equals 1. So there's subtraction. You know what to do. This will be log x over 2 equals 1. And then remember, the base is 10. So log x over 2 base 10 equals 1. Express it in exponential form. X over 2 equals 10 to the 1. Then cross multiplication, you're going to get x equals 20. And that's the solution. Example 7, log 2 base 8 plus log 4x squared base 8 equals 1. So they have the same base. We can combine those those logarithms into single logarithm. And remember, the property log b base b is equal to 1 when the power and the base are the same, so it is equal to 1. So we can express it as log 2 base 8 plus log 4x squared base 8 equals log 8 base 8. So let's combine the terms on the left side of the equation. That will be log 2 times 4x squared base 8 equals log 8 base 8. So now it will become log 8x squared base 8 equals log 8 base 8. So they have the same base, so we can equate 8x squared and 8. So now we're going to have 8x squared equals 8. Then divide both sides by 8. So we have x squared equals 1. Get the root of both sides of the equation. So x is equal to positive or negative 1. Or 1 and or negative 1. So these are the answers to our equation. So we can also do that for natural logarithms. Example 8, ln n squared plus 12 equals ln negative 9n minus 2. So we can just simply equate those. N squared plus 12 equals negative 9n minus 2. So since we have square here, we expect our expression to be quadratic. So let's equate it to 0. So now this will be n squared plus 9n plus 12 plus 2 equals 0. 9 squared plus 9n plus 14 equals 0. So we can apply factoring here. We can factor those or that trinomial into n plus 7 times n plus 2 equals 0. So equate both factors to 0. First one, n plus 7 equals 0. So n is equal to negative 7. And at the other factor, n plus 2 equals 0. So n equals negative 2. So we can say that the solutions of this logarithmic equation is negative 7 and negative 2. example 9, ln2 minus ln3x plus 2 equals 1. So we can also combine it, ln2 over 3x plus 2 equals 1. Then remember, so log a base e is equal to ln a, and log e base e is equal to 1. So ln, we can change it to log with base e, and then 1 we can change it to log e base e. So now our given is log 2 over 3x plus 2 base e equals log e base e. So now they have the same logarithm with base e, so we can equate 2 over 3x plus 2 equals e. Then let us continue our solution. So apply cross multiplication, that will be 2 equals e times 3x plus 2. So distribute e, this will be 2 equals 3xe plus 2e. So interchange the terms in the equation by a symmetric property. Let's put x in the left side of the equation. Now we have 3xe plus 2 equals 2 transpose 2e. So this will be 3xe equals 2 minus 2e. Then divide both sides by 3e, so that x will be the only term on the left side of the equation. So now we have x equals 2 minus 2e all over 3e. And this is the solution for our logarithmic equation. Actually, e is a natural number. It has a numerical equivalent. So you can change e to its numerical equivalent, then you can get a numerical answer. So another example, example 10, negative 6 log x minus 3 base 3 equals negative 24. So if you have given like this, you can divide both sides of the equation by the number based on the given. So in this case, we can divide both sides of the equation by negative 6. Okay, so we're going to have log x minus 3 base 3 equals 4. Then to solve this, change this into exponential form. We're going to have x minus 3 equals 3 raised to 4. So x equals 81 plus 3, because 3 to the 4 is 81. Then we transpose negative 3, that became positive 3 in the right side of the equation, and 81 plus 3 is 84. So now we have x equals 84. So for the practice exercise, solve each logarithmic equation. If you have questions, just send me a message. Always remember, class, do mathematics to learn mathematics. Practice, improve, and stay curious. Keep safe, stay healthy, and God bless everyone. See you next week for our next topic.